In this video here, we're going to see how to find the points of intersections of two circles based on this example here. Example 1. Find the points of intersections of the following circles. So in here, you are given two circles, circle 1, circle 2. And we would like to find out that what is happen to be the points of intersections between these two circles. So the techniques to find out the point of intersection will be, first of all, I will begin my solution with, I state the first circle equation as equation 1, the second circle equations as equation 2, and I'm going to solve these two equations by simultaneous equation in order to find out the points of intersections. After I have stated as equation 1 and 2, what I'm going to do the next is that I'm going to make use of these two equations to get rid of the square terms. I want to get rid of the square term by either using equation 1 minus equation 2 or 2 minus 1. Either one will do. And in my solutions here, I'm using equation 2 minus equation 1. So as a result, when the time I have equation 2 minus equation 1, we use the left-hand side term, minus with the left-hand side term, the right-hand side term, minus with the right-hand side term. And as a result, we find out that we have the answer as 7x plus 7y minus 21. Negative 3x minus negative 10x, 7x as a result. Negative 3y minus negative 10y, 7y as a result. 4 minus 25, we get negative 21 as a result. Okay, so now, after I get these equations here, after using 2 minus 1, I find out that I have a common factors of 7 for each of these terms here. So the next thing what I will do is that, let me try to simplify these equations here. And then the next thing what I do is that I want to write either x in terms of y or y in terms of x to create a third equations. So in my solutions here, I will have y equals to 3 minus x, where I write y in terms of x to create the third equation. And the use of this third equation is for us to substitute into either the first or second equation to find out what is the x value for the points of intersections. It's either you can substitute into first or second equation, either one will do in this case here. So for example here, I substitute the third equation into the second equations. Then as a result, what I have is that all the parts with y, I'm going to substitute with 3 minus x, where this part originally is y squared, 3y. I substitute with 3 minus x for the position with y. Then what we do the next is that we expand the quadratic, expand 3 multiply 3 minus x. So the expansions of 3 minus x squared, it will give me 9 minus 6x plus x squared. The expansions of negative 3 multiplied with 3 minus x, it will give me negative 9 plus 3x. The rest of the term, just bring forwards. The next line, we try to simplify the terms. We'll find out that we have the quadratic equations, 2x squared minus 6x plus 4 equals 0, where you can see that x squared plus x squared, they give us 2x squared. The x term, negative 6x, negative 3x, plus 3x. As a result, we have negative 6x. Then lastly, the constant 9 minus 9 plus 4. So as a result, we have plus 4. So from the quadratic equations that we have, we try to solve it. And in this case here, before I solve the equations, I notice once again there is a common factors between the x squared term, the x term, and also the constant, which is happen to be having the common factors of 2. So the next time what I'm going to do is that I'm going to divide the equations with 2. Therefore, I have x squared minus 3x plus 2. The reason why I'm doing this is that so that later when the time I do factorizations, the answer that I have will be correct. And I believe this answer here that you people have from factorization, it depends on calculator. So in order that your answer is tally with the calculator answer, so I will suggest that we make the x squared terms here with the coefficients of 1. So as a result, we factorize. We have x minus 1 multiply x minus 2 equal to 0. And from these factors here, we find out that the two possible x value will be the first one, x equals to 1, or the second one, x equal to 2. Now we find out the x coordinates. This is actually the x coordinate of the point of intersections. And now we would like to use this x coordinate, this x value here, to find out the corresponding y coordinate. And your choice here, I will suggest that we make use of the third equations. The third equation, this one, the linear equations, to find out your y, because it will be the simplest one and the most accurate one. So we substitute the corresponding x into the third equations. What you happen to find out is that when x equals to 1, you have y equals to 2. When x equals to 2, you have y equals to 1. And since the answer 1, the point of intersections, let us write down the coordinate of the point instead of leaving it in the form of x1, y2. But we write in coordinate form. So the final answer, the intersections point will be, you group x1, y2, you group x2, y1 to form the point 1, 2, when x equals to 1, y equals to 2. And then the other point will be 2, 1. And this is how we find the intersections points of two circles.